When you were in earlier grades in elementary school and middle school, when we talked about parallel and perpendicular lines, we had kind of a very specific definition of them, okay? Parallel lines, let me get this written down. This is a hard word. Parallel lines are two lines that run alongside each other, but they never touch because they're the same distance apart. So like the best example I could think of that was, railroad tracks, because, obviously railroad tracks have to stay the same distance apart, otherwise, the train gets all crazy and big mess, okay? So that is still a valid definition of parallel. When we look at perpendicular, the definition we had of perpendicular was two lines that cross at a right angle, okay? Also, still a perfectly wonderful definition of perpendicular. But as we get in higher and higher grades in school, and as we take more detailed math, we're going to start to refine our definitions. So we're going to put an algebra twist and have the algebraic definition of parallel and perpendicular. So when we talk about parallel and perpendicular now, we're going to look at the coordinate plane. And when I look at these 2 points, what I notice about them is they have the same slope, they just have different y-intercepts. And they're equidistant apart. So every ordered pair is the same distance apart from each other. So every x value, so this x value, 0, x, 0 something and 0 something else, they're the same distance apart, okay? But the biggest thing about them is they have the same slope and they have different y-intercepts. Now this part right here, this different y-intercept, it's not as important because really if they have the same slope and the same y-intercept, they're the same line. So obviously they can't have the same y-intercept. Okay, they have to have different y-intercepts, but they have to have the exact same slope. Okay, so that's our official definition of a parallel line. That's our algebra definition. They're two equations with the same slope. Now likewise, when we look at perpendicular lines, okay, there's my x-axis and my y-axis, okay? I have two lines, so obviously I have one line that's positive and one that's negative. So I know that they have opposite signs. Okay, they are opposites. What isn't as obvious, just from looking at this, is that my rise and run are backwards. So if I fall 3, run 2, on this one, I'm going to rise 2, run 3. Okay, it's kind of hard to say, but what that means is their slope is also reciprocal, and these are both my slope. Okay, it has to be both. Again, I know that they're opposite signs because I have positive slope on one, negative slope on the other. They're reciprocal because they are, and if we actually do some rising and running with it, you'll see why that happens. But let's just take my word for it at this point. Okay, so opposite sign, opposite mathematically refers to integers. Okay, so we're talking about positives. So the opposite of a positive is a negative, and the opposite of a negative is a positive. Okay, so that's how when we look at them. So one of them is, this one has negative slope, its opposite has positive slope. It's perpendicular, buddy. Okay? And when I look at reciprocal, I'm looking at a flipped fraction. Okay? So for example, if the slope was 2/3, I'm going to flip that, it becomes 3/2. Okay? So a rise of 2, run of 3 turns into a rise of 3, a run of 2. Now likewise, if my slope was 3, and I needed to flip it, I would have to write it as a fraction and then flip it to become 1/3. So 3 and 1/3 are reciprocals. And then if I had 1/5 as my fraction, when I flip it, it becomes 5 over 1, which is 5. Okay? So that's what we're talking about when we talk about our flipped fractions. Now one other thing to talk about is that the x and y axis are perpendicular. So if I have a line that's parallel to the y-axis, it's going to be perpendicular to the x-axis. I know that doesn't really mean much, but remember, if I ask you for something, like if I say, what line is perpendicular to the x-axis, I want you to say the y-axis, or a y, some undefined slope. Okay. Now, speaking of undefined slope, I have another video about Hoy-Vux. Don't forget about that. Okay. But let's take a look really quickly. Let's see what kind of things we might be asked. Okay. So let's say I have two. I'm asked to find a parallel line. So let's say I have an equation y equals 1/2 x minus 3. Okay. I have 1/2 x minus 3. If I'm looking for something that is parallel to that, okay, I want it to have the same slope, okay, but a different y-intercept, obviously, because it won't be the same line, okay. So I might have y equals 1/2 x plus virtually anything except -3, okay. Now, I might also be asked to find something perpendicular. So if I do, it has to be reciprocal and opposite. Okay? It has to be both. It can't just be one or the other. So my slope was 1/2. I have to transform that into reciprocal opposite slope. Well, to make the reciprocal, I put 2/1. To make its opposite, I change it from positive to negative. So that means my new slope is -2. So an equation of that line might be y equals -2x plus anything. And for perpendicular, we really don't care about y-intercept. They could have the exact same y-intercept and they'd be fine. Okay? So that's kind of a more general way that we've been asked about parallel and perpendicular. But let's think about the way that we've been seeing it in class. Okay? So in class, let's say I have the equation y equals 3/4 x plus 2. Okay? Let's say I say to you, I want a line that's parallel and it goes through the point 411. Okay, so what that means is they've given me all the information I need, but I have to pick it out of the original equation. So I don't want this line. I want a line that's parallel to it that goes through this point. Okay, so I know that my slope, because it's parallel, has to be the same. So my slope is going to be 3/4. And I have this point. And what do I use when I have the slope and a point? I use point-slope form. Okay, so I have y minus y1 equals m, x minus x1. Okay, this is x1, this is y1. Y minus 11 equals 3/4 x minus 4. And then I'm going to keep simplifying this. Generally when they ask me for a line that's parallel, they want it in slope-intercept form. Okay, or perpendicular, they want it in slope-intercept form. So I'm going to keep on going. Okay, y minus 11 equals 3/4 x. 3 times -4 is -12, divided by +4 is -3. Okay, so now I want to get y by itself because I want it in slope-intercept form. So I'm going to add 11 to both sides. I get y equals 3/4 x plus 8. Now, if I want to check that and confirm that I did it right, I go into my calculator. Oopsie. I put 3/4 x plus 8, and I look for that coordinate. So they said it needed to have a slope of 3/4, which my equation does, and it needed to go through 411. So I'm going to look for 411, and hey, look, it's right there, 411. Okay? So I've checked it, and I know that this is the point I'm looking for. Now, they might ask me to convert that into standard form. They might ask me to do a lot of things, but at least once I get into slope-intercept form, I can graph it if I need to. I can convert it into another form if I need to. Okay? Now, likewise, if they ask me for a perpendicular line that goes through, let's say, 3, -2, I would have to do the same thing. I have the point. I need to find the slope. So my slope was 3/4. I need it to be reciprocal and opposite. Okay? Let's make that a longer arrow. Okay? So I need to flip it to 4/3 to make it reciprocal. It's positive. I need to make it negative. So this is my new slope. Okay? And now I have the slope and a point. I'm going to go back to point-slope form. Y minus y1 equals m, x minus x1. Okay? So y minus -2 equals -4/3 x minus 3. Let's clean this up. Y plus 2 equals -4/3 x minus 3. Let's distribute this. Y plus 2 equals negative 4/3 x plus 4. I'm going to subtract 2 from both sides, and I get y equals negative 4/3 x plus 2. Boy, I hope I'm right. Okay, so I'm going to put that in the calculator now. I'm going to put negative 4/3 x plus 2. Cross my fingers, hope I did it right. And I'm looking for the point 3, negative 2. Ooh, go me. I can algebra. There it is. Okay? And that's pretty much, that's the hardest one I think you're going to see. That's the hardest kind of thing you're going to see. And like I said, they might ask you to convert this into standard form. You can do that. We got another video on how to do that, okay? They might ask you to leave it in, slope-intercept form. They might ask you to look at a graph. Okay? There's lots of things they might ask you to do. But once you get into slope-intercept form, that makes a lot of things a lot easier.